So we've seen that there's 4 different types of stationary points. We've got maximum and minimum turning points, and then we have horizontal points of inflection, which can go in either direction. So once we've found the flat spots on our curve, or the places where the gradient is 0, we need to actually analyse the gradient on either side of that spot so that we can tell which of these 4 types we have. Now, having a look at what we've got here, the gradient on this side, to the left of this one, is positive, but on this side it's negative. Here we have negative followed by positive. Over here, it's positive all the time, and this one is negative all the time. So we're going to use the first derivative, which is our gradient formula, to analyse our stationary points and see which one we've got. So 3 steps here. The first step is just to find the stationary points by differentiating your function and then letting f dash x, or dy dx, whatever you've named it, equal 0. That will tell you the values of x where you've got a flat spot. Step 2, draw up a table of slopes. Now we've seen a table of values that compares x and y. We want to look at x and the slope, in other words, f dash x, and see what we've got at each of our places. Now we want to look at our stationary points. They'll have a gradient of 0, but we want to look on either side so that we can see what situation we've got. Step 3 is you draw the slope as positive, like this, a little symbol, negative, like that, or 0. And that reveals the shape and the nature of the stationary point. Now in our example, we are going to use the stationary points and a table of slopes to sketch this function. Now I can see it's a cubic function, so before I even start, I know that it's got this basic shape. It's a positive one, so it's either got a general wobble or a big wobble in it. Now if it has a big wobble, it will actually have some stationary points, and it will have 2 of them. And you'll find that a cubic curve will either have 2 stationary points, or it will have just 1 if it's just got a flat spot, or it might even have none. So finding these stationary points really helps us to see the nature of the curve when we go to graph it. Now, first step, we need to see where the stationary points are. And stationary points happen when the gradient is 0. So first I need to differentiate this and then let dy dx equal 0 and find the values of x where that happens. So differentiate one term at a time, and that gives us this. Now if I let dy dx equal 0, that means on the next line I can just write a 0 where the dy dx would have been. And on this side, I can see that if I'm finding values of x that let this happen, factorising it is going to be the easiest way to do that. Now, all 3 of these terms have a 3 in them, so I'm going to start by bringing 3 out the front because that's going to make my life easier. And then on the next line, I can factorise it more fully, and I can see I've got -3 and -1 here, and we get this. So now to think through what values of x would make dy dx equal 0, well, x equals 1 or x equals 3 would do that. So I'd write when x equals 1 or 3, I've got stationary points. And you can just jot that down in point form, whatever you like. It's not essential you write this, but I like to sort of keep it straight in my mind what it is that I've just found before I move ahead. Now, a stationary point is a point on the Cartesian plane. It's got an x value and a y value, in brackets with a comma in between. I've only found the x values of both points, so it makes sense now, so that I can graph where they are to find their corresponding y values. So I would write 2 little sentences here. When x equals 1, or when x equals 3, what's y? Now, the biggest mistake that people make here is looking back to the first thing that we wrote down with our own pen. The first thing we wrote down was dy dx, and it's so tempting to just think, oh, I've just got to sub in x equals 1, and lots of students will make a mistake and sub 1 into this. But if you sub 1 in here, you're going to get 0, because when x equals 1 or 3, the gradient is 0. We want to find what y is, and y was in our question. This is the statement we need with y's and x's being compared. So go ahead and sub x equals 1 in here, and find out the value of y. So take your time doing it so you don't make a mistake. We have 1 cubed minus 6 lots of 1 plus 9 lots of 1 minus 4. So that gives us, what's that, minus 5, 4 minus 4, that's 0. Now that gives me the point 1, 0. And just writing it down as a coordinate pair there is a good idea, because then when you go to graph it, you're less likely to make a mistake and accidentally use the wrong x or the wrong y value. So I've got this point here, 1, 0. Now in x is 3, we're going to have 3 cubed, which is 27, minus 6 nines, which is 54. So that's minus 27 so far, plus 9 threes, so plus 27, that gives me 0, minus 4, that will give me minus 4. So now I have the point 3 minus 4, and that's also a stationary point. Now that means that I can find it over here, 1, 2, 3, 1, 2, 3, 4, and put a little dot and mark the point. But I can not only put a dot, I can actually put a little flat spot on both of those. And that reminds me when I'm graphing that it goes through there, flat. All right, now I need to do my table of slopes so that I can see what the curve's doing on either side. So the values of x that I'm interested in, well, I found 1 and 3. So I'm interested in those, and I want to see what the slope is doing on either side. So my table of slopes, looks something like this. Now I've left space to do an x value that's smaller than 1 and bigger than 3, and one that's in between the two, so that I can see what my graph is doing. So pick some nice round numbers. We could use 0, 2 and 4 here. We already know that dy dx will be 0 when x is 1 or 3. Now we need to sub x equals 0, 2 and 4 into dy dx. Now you can either use this form of it, or you can use the factorised form, whichever you like. When I'm subbing 0 in, I think I'd rather throw it in here, because I can see that these terms will be 0 and I'll have 9. That was easy. Now a slope of 9, that's a pretty steep section of the curve. It's going up, and 9 is a positive number, so it's going this way. Next, since I'm finishing up here, I'm going to leave my pen high and show the shape of the curve where it's flat going across. That way I can see it's going up and then across. Now in x is 2, I might sub it into this one. 2 minus 1 is 1, so I've got 3 ones are 3, and 2 minus 3 is minus 1, so I'm going to have negative 3 here. So it's a negative slope that I'm wanting to draw here. Yes, it's not quite as steep as this one, but literally just drawing a line like that tells me that this must be a maximum turning point when x equals 1, because I've got positive slope on one side, negative slope on the other side, and see how we can see there the nature of the turning point. So that means over here where I've drawn a flat spot, I could actually even draw just a little bit of a curve to it, just a hint of a curve, so that I know what shape I have there. Now, if I've got a negative gradient here and the next part is a 0 gradient, it makes sense to put my pen and keep it low for this flat bit, so that I can see there's two options now. It's either going to go like this and then flat and then up again, or like this and then flat and then down even further. So investigating what the slope is when x is 4, well 4 minus 1 is 3, 3 3s are 9, and 4 minus 3 is 1, so I've got a gradient here of 9, so that's going positive again, so I can see that this must be a minimum turning point. So I can do a little bit of a minimum curve here, and now I've got the basic shape for my graph. I've got my minimum and my maximum turning point, and if I wanted to, I could go ahead and find the x and y intercepts here. Easily enough, I've already got this one, and to find this one I could let x equal 0, and I'm going to have minus 4. Obviously my graph's not to scale, but that's okay. It would have to go down steeper, wouldn't it? It'd have to come down more like this. And then over here I could let y equal 0 and solve this if I needed to. The question hasn't asked for it, so I'll probably stop there. I've got the basic shape for my graph.